Hello everyone, I'm Fabio Vito. I'm a postdoctoral researcher at Scuola Normale Superiore of Pisa in Italy, and I'm going to talk about new X-ray observations of a ratio 4 starbursting protocluster. So this is the protocluster. Its name is Distant Red Core, DRC, ratio 4. It was first selected through some millimeter and millimeter observations, and it consists of at least 13 spectroscopically identified dusty star-forming galaxies at ratio 4. So on the left you can see the very inner region of the structure, so the core of the protocluster, and on the right you can see some other galaxy members in the outskirt regions. So the total star formation rate and gas content on DRC are very high. We have a star formation rate higher than 6,000 solar masses per year, and a total molecular hydrogen mass in excess of 10 to the 12 solar masses. Also, high-resolution HST and ALMA imaging resolved most of the protocluster members into multiple interacting clamps, so there is evidence that most of the members of DRC are going through galaxy merger or interaction phases. Moreover, Muse observations reveal the presence of a Lyalpha blob. These kind of objects are often associated with nearby obscured AGNs that can be the powering sources of the Lyalpha blob. So in DRC we have a lot of gas, ongoing galaxy interactions, and the Lyalpha blob, which may indicate the presence of a hidden and obscured AGN activity. So we observed DRC with Chandra for 140 kiloseconds to investigate the AGN content of this protocluster, and since all of these elements are kind of indicating that there may be an enhanced AGN activity in this structure. So this is the Chandra full band image of the core of DRC. We detected the galaxy named DRC1, which is the most gas-rich and star-forming member of the protocluster, and it is also being resolved into 3 distant clamps, star-forming clamps in interaction. The Chan observations reveal that this millimeter source hosts an heavily obscured AGN with moderate luminosity. We also detected DRC2. This is a Compton-thick AGN candidate with very high luminosity. HST observations reveal that DRC is also going through a merging event. And finally, from previous ride observations, we know that there is a third AGN in this structure, DRC6. This other galaxy here is actually a radio galaxy. So we have in total 3 AGNs out of 13 identified members of the structure, which translates into an AGN fraction of about 25%. This is in line with what is found for field some-millimeter galaxies and for other protoclusters at high redshift. It is interesting to note that the 2 X-ray selected AGNs are hosted in the 2 most gas-rich and star-forming members of the protoclusters, and also both of them are going through a merger phase. This suggests that there is a strong link between the gas content of galaxies, merging, and nuclear activity, and possibly obscure nuclear activity. So I'm going to spend a few slides talking about DRC2. On the right you can see the X-ray luminosity versus column density plane for quasars and AGNs, and DRC2 is located in the upper right corner of this plane. This means that its luminosity is similar to optically selected quasars, which you can see here in blue and green, so very luminous quasars, but DRC2 is much more heavily obscured. On the left you can see the hard X-ray image of DRC2 with ALMA contours plotted in green and Muse contours of the Lyalpha blob plotted in blue. The Lyalpha blob is located very close to DRC2, which means that probably DRC2 is the powering source of this Lyalpha blob. So here you can see Lyalpha blob color-coded according to the velocity of the line. Again, given its luminosity and proximity, DRC2 is the most likely powering source of the lab, and possibly this happens through photoionization, although we also propose that shock-induced ionization due to a possible molecular and dusty outflow launched by the powerful quasar can also power the Lyalpha blob, and of course we need new Muse and ALMA observations to test this hypothesis. So I'm going to leave here my conclusions, and thank you for checking out this presentation. If you're interested, and you can find more details in the paper at the bottom of the page. Thank you.